So today we'll be dealing with the next portion or the main portion of the chapter motion in one dimension or motion in straight line. So since we have talked about instantaneous velocity, instantaneous acceleration, average velocity and acceleration, we will now deal with the next main heading, that is graphical representations of all. Right. Of all, I mean the displacement time graph, distance time graph, velocity time graph, acceleration time graph. I'm not going to separate it individually, we will club it. Okay, so suppose you know that the slope of a distance time graph, or let's say slope of a displacement time graph, what does it give? It gives you velocity. Right. Similarly, slope of distance time graph will give you what? Speed. I've told you, right? Before this, I have told you slope of what and all. Basically, what and all gives what. Suppose this is me, right? Or you guys. You are moving from your home to, say, school, right? Say it is of 2 kilometers. You're to and from moving. You are coming back also, and each distance travel is of 2 hours. That is, from home to school it is for 2 hours, from school to home is also for 2 hours. Okay, if you plot a distance time graph, how it would be that? It is 1 2 3 4, 1 2 3 4. Let's say this is 4, right? That is during the distance time graph, right? During the first 2 hours he has traveled, or you have traveled for 2 kilometers. So this is a point, right? For the next 2 kilometers, that is now the distance is 4 kilometer, and that is for 4 hours, right? So when you join the points, the graph will be like this, right? And the slope is this one, that is theta, that is tan theta is equal to y, or y2 minus y1, right? Let's say this section, let's take this triangle, right? So it will be 4, right? It is a y divided by x is also 4, so it is 1 meter per second. Simple. That is the speed of the scenario. But if I am plotting the same example and I'm plotting a displacement time graph, right, that would be a little bit different, right? Let's say this is 1 2 3 4, 1 2 3 4, right? So first of all, at the second hour, or in 2 hours, I have reached 2 kilometers, means obviously the point is here, right? But next 2 hours I am coming back to my origin itself. So origin is this, right? This is my home, is my origin. So I'm coming back to my origin or home, means the next position is here, right? So when I plot the graph for this example, for displacement time graph, right, this is displacement, okay, it's a displacement time graph, then the graph looks like this, right? So this slope 1 is positive, as you can see, right? Whereas this slope is, second one is negative. Easily understood, right? Now there is a small thing which is very important while studying graph. See guys, when I take angle theta, right, this is the angle I am supposed to take, this is angle theta, right? Let's say this is theta 1, right? Now, so this angle theta 1 is the slope, right? Whereas for the slope 2, which angle I am supposed to take, this one or this one? You are supposed to take this one, okay? That is how the direction is supposed to be taken, in the right side, right? Whenever you're considering the slope, you have to consider the right side angle of that slope. So the right side angle is this one, right? And the angle is calculated from the, obviously from the straight line. So this is the straight line, the angle is taken from this direction, okay? This is theta 2, so the angle or slope of this one is this theta 2, and slope of this one is theta 1, right? And you can see theta 1 is less than 90 degree and theta 2 is greater than 90 degree. Simple. So I will give you a short trick. If theta 1 or if the theta angle of the slope is less than 90, then the velocity is positive. Right. If the theta 2 or the angle is greater than 90 degree, the velocity is negative. Keep that in mind. Make it as a short thing and keep it in your mind itself, or you can write on the paper. It's okay. This much is clear, right? So that means when I am moving from home to school, the velocity is increasing, right? And velocity is increasing in positive direction. Whereas when I am moving from school to home, velocity is increasing itself, but in the negative direction. Vector, right? Clear? Now some of the terms which you have to know. Okay. Why it's not moving? Okay. The next topic or something which you have to know is how does a uniform displacement time graph or a non-uniform displacement time graph looks like, right? If you're given a graph like this, right, straight, this is your displacement time graph. So this is the graph for a uniform displacement time graph, uniform, whereas that is equal displacement in equal intervals of time. And if the displacements are unequal in intervals of time, so the graph will look like this. So this graph is uniform and this is non-uniform, right? Simple. So I hope you understood for uniform and non-uniform. See, if it is uniform velocity, also the graph looks like this, just the axis changes to this becomes v, right? So uniform velocity, non-uniform velocity, uniform acceleration, non-uniform acceleration. So uniform and non-uniform graph is like this, and you can just change the axis according to the question. Clear? If equal changes of the y-axis happens for equal intervals of time, then that is uniform. If the equal intervals of time is not producing a equal changes in y-axis, then it is non-uniform. Simple, right? Suppose I am asked to draw a displacement time graph of a body which is at rest. It is not at all moving. How would you draw? Like this, right? Initially it was 2 kilometer, it still remains in 2 kilometer, still remains at 2 kilometer. Clear? These are some of the basic things, guys. Clear? Right. Now if you are given the same graphs, okay, let's move on to the same graphs itself, right? Our uniform velocity, uniform displacement time graph I'm going to take. So you are asked to draw velocity time graph for a uniform displacement time graph. So how would you draw it, right? How would you draw it? So this is, I'm drawing it again. This is our uniform displacement. I'm writing S or D, D, it's okay, right? So this is my uniform displacement time graph. So that means, see, slope here theta, this slope is also theta, this slope is also theta. So that means the slope is remaining constant. Slope is constant means the velocity is constant. So the velocity time graph for this displacement, right, equivalent, if I am drawing, it is like this, right? The velocity is remaining constant, right? Simple. Now similarly, this displacement time graph, this is a non-uniform displacement time graph, right? So if you are asked to draw what will be the velocity time graph for this, how would you draw? So that means this is a slope here for this point. For this one, the slope is increasing, right? So that means the velocity is increasing constantly. So the velocity time graph will be like this. So I hope you understood. All right. So as I can see from the displacement time graph, I can draw a velocity time graph equivalent to it. Simple, right? It's not that much of tough, right? So now since we have reached velocity time graph, there is a small thing which has to be mentioned, guys, what does the slope of a velocity time graph gives you? I can draw from here itself. Let's say, okay, I'm taking this point, right? So this becomes y and this is x, right? This is the slope. So tan theta is equal to y by x, right? So what is y here? That will be some v1 velocity quantity. So let's say v1. And what will be x? That is time, right? Let's say t1. So what is velocity by time? It is acceleration, right? So slope of velocity time graph gives you acceleration. Remember, slope of a displacement time graph gives you velocity. So I like this slope, right? Displacement time graph gives you velocity, whereas velocity times graph slope gives you acceleration. Simple, right? Now we'll move on with the earlier example itself. Suppose we told you this is velocity, this is time, and the line is straight like this. And I told you slope of velocity time graph gives you acceleration. So here I'm going to take each point slope. So this is theta 1 or theta. This is also theta, right? So the slope is not at all changing. I can say the acceleration is what? Constant, right? The acceleration is constant. So if the graph changes like this, like this is velocity time, and the graph is like this, means the object is having constant what? Velocity. Velocity is constant. Constant means the velocity is not changing. Velocity doesn't change. Mean if the initially the object is moving with a velocity of 2 meter per second, means still now it is moving with the velocity of 2 meters per second itself. So does it have any acceleration? No. So by looking at the graph itself, we can say whether the acceleration is constant or acceleration is zero, right? Similarly, I'm going to tell you some small tricks. By looking at the graph itself, you can say whether the acceleration is positive or negative. And relating to that, we can say by looking at the graph itself, you can say about something about velocity, acceleration, as well as speed. Okay, let's move. Let's take an example of another graph of a displacement time graph. Okay, let's draw a displacement time graph. This is displacement, this is for time, and you're given a graph like this, right? So you are asked what is the type of velocity, or whether it is positive or negative, or what is the nature of acceleration also. So how can you do it, right? Simple way. Velocity I can say easily. How? See, suppose I take a point here, the slope is like this, right? Whereas if I consider a point here, its slope is like this. So initially the theta 1, this is theta 2, or say the theta 2. So I can say the angle is increasing. When angle is increasing means tan theta increases. When tan theta increases means velocity is increasing, right? That much is easy to understand. And you see both this angle theta or theta 2 is less than 90 degree, right? I told you when angle is less than 90 degree, the velocity is positive. So velocity is positive and it is increasing in nature, right? This and all of 90-degree cases I have discussed earlier. I hope you remember this one, right? Clear? So let's move on, sorry, with the examples again. So I have confirmed about velocity is positive and it is increasing, right? So high, that means velocity is positive and increasing means, so if I take two scenarios, suppose this is v2, this is v1 velocity, right? So new velocity, or the second velocity v2 is greater than v1, right? So and let's say t1 is a time period or time duration for velocity v1, and t2 is a time duration for velocity v2. Then acceleration is v2 minus v1 divided by t2 minus t1, right? Simple, right? So that means v2 is greater than v1, means now acceleration is what? Positive. Simple, clear? So positive velocity, increasing velocity, so acceleration is also positive. Simple as it is, right? Now similarly, let's move on with the next section. I will give you a small trick. It's okay. Now let us take the next example, guys. So this is our graph like this. Again, this is displacement time graph. So the slope of displacement time graph gives you velocity. Now let's say this is the first duration. Okay, this is second duration, right? So I am calculating, this is a tangent here, and for point 2, let's say the tangent is here, right? So see, so second point's tangent is theta 2, this is theta 1. So I can say theta 1 is greater than theta 2, right? Or when theta 1 is greater than theta 2, that means tan theta 1 is greater than tan theta 2. Or I can say v1 is greater than v2. That is, first the velocity was high, then the velocity decreased, right? Or I can say from the figure itself, the slope is decreasing, right? When slope is decreasing means velocity is, see, my question is whether the velocity is negative or positive, or acceleration is negative or positive. Velocity is decreasing, right? Initially the velocity was high, the velocity is decreasing, so that means acceleration is negative, right? See, what is acceleration? It is v2 minus v1 by t2 minus t1, and I am telling you v2 is less than v1, so it will be a negative quantity. So acceleration is negative, keep that in mind, right? So this much if it is clear. Now I am going to give you a short trick. See, when you are given a displacement time graph and the curve is upward, the concave is upwards, right? Then the acceleration is always taken as positive. When the curve is upward, the acceleration is positive, right? When the curve is downward like this, when the curve is downward like this, right, the acceleration is always negative. This is a short trick, guys, keep that in mind, right? Clear? Right? And when is acceleration 0? When the velocity time graph is like this, right? Clear? Right? So whenever you are having graph, displacement time graph, right? So I'm just a minute. So when does this velocity time graph will be constant? When the what displacement time graph is like this, right? Clear? When the displacement time graph is like this, then the velocity time graph will be like this, right? Why? See, this means, what does this straight line indicate? That equal displacement in equal intervals of time. So that means the velocity is constant. When velocity is constant, the acceleration is 0. Clear? Keep that in mind, right? I hope you understood the scenarios where acceleration is positive, negative and 0. Now we'll do a little bit problems, right? I'm drawing a figure. Okay, oh, it didn't join here. Right, and I'm drawing like this, right? This is my displacement time graph, right? My question is, what is the nature of velocity, whether it is positive, negative, whatsoever. And after the two questions, I will give for or go for a basic other theory section. Then again we'll move on with the questions itself. So here the curve is upwards, right? So when the concave or this concave section is upward, I can definitely say acceleration is positive. This much clear, right? Now when we see about what the angle, let's take this point, right? Let's say this point, right? Let it extend it. This is a right angle, right? Right direction angle, right? So this is our theta, and theta is greater than 90 degree. This is how you angle, take the angle, okay? Extend it, meet it with the axis, right? And take the angle in anti-clockwise direction, right? And you say angle is greater than 90 degree means velocity is negative. Acceleration is positive, velocity is negative. Clear? Right? Keep that in mind. Now similarly, I'm giving another graph like this, and this is our displacement time graph, okay? And again you are asked what is the nature of velocity and acceleration. Again this is a concave which is downward, so acceleration is negative, right? So draw a straight line like this. What is the angle here? So not this angle, okay, the angle is this one, right? Anti-clockwise, right? So this angle theta is greater than 90 degree, so again velocity is negative. Velocity is negative, right? Clear? So this is how you can take each and every scenario and then can understand whether it is equal to positive or acceleration positive, negative, or sorry, if the velocity is increasing, decreasing, etc. can be told. We will do a little bit more problem. Before that, there is another theory section which we have to deal. That is area under a velocity time graph. Right? What does an area under velocity time graph gives you? So velocity time graph I am dealing little bit, right? So in velocity time graph, slope gives you what? It gives you acceleration. We talked about it, right? Whereas the area under a velocity time graph gives you displacement, right? If you don't understand, see, this is velocity, this is time, and I plotted a graph like this, right? So this is velocity v1, this time period is t1, this is origin, right? So what is the area? This is a rectangle, right? So what is L into B, right? L into B, right? So it will be what? V1, sorry, area will be equal to, as per the diagram, V1 into T1, right? So actually what is V into T? This displacement, right? So I can say area under velocity time graph gives you displacement. Keep that in mind. Whereas slope of a velocity time gives you acceleration. Here, this is a very important theory part, guys. Clear? Now, similarly, we'll do a little bit problems. Right. So I will now do regarding the entire topic which we which I taught you guys today. Based on that, we'll do all the questions. Okay. Suppose this is the graph, right? This is O, this is A, and this is B, right? Say this is 5, 10. This is for second. This is meter per second velocity. Clear? And this is at 10. You are asked what is the acceleration and what is displacement. Total displacement covered by an object if it is having a velocity time graph like this. So first of all, you have to split. So acceleration for OA segment. This is OA segment. Acceleration means slope of velocity time graph. That means I am supposed to find this slope, right? So what is this? Tan theta, right? Tan theta is equal to this segment, right? This segment, how much is the height? 10. So it is 10 y by x, right? 10. And what is the x segment here? This value, that is 5. Or you can write 2 meter per second squared is the acceleration for the segment OA. Simple. Clear? Right. Now we'll go for the segment, next segment, which is as per the diagram, it is what? AB, right? AB, there is no slope, right? When there is no slope means the acceleration is 0, right? So for AB, acceleration is 0. For OA, the acceleration is 2 meter per second square. Clear? Similarly, let's move on with the displacement. So from velocity time graph, how can I calculate displacement? You just have to find the area under the graph, right? So for AB segment, if you are asked to displace, ABL, not AB, it's OA, right? Let's start with OA, right? The area under this segment OA is a triangle, that is half into B into H. So base is this much, that is 5, and what is height? This much, that is how much? 10, right? So you'll get 25 meter as the answer, right? So the displacement for this much segment is how much? 25 meter. Now similarly for AB, it's a rectangle, right? So L into B, What is length? Let's take this one. Length is 5, right? 10 minus 5, so 5. And what is this base? Let's take this one as base, so it is how much? 10, right? 5 into 10, so it is 50, right? 50 meter. Clear, right? This much clear. So total will be 25 plus 50, 75 meter as a total displacement. Clear? It's very easy, right? Similarly, let's move on with another problem. We'll cover a maximum problems, guys, so that it will be easy for you guys to understand the graphical representation. Right? Suppose you are asked a question like this. This is displacement time graph and you're given A and B, right? And you are asked which object out of A and B is having higher velocity. Very easy, right? It is A because its angle, let's say it's theta A, and B is having angle theta B, right? You can say theta A is greater than theta B from the figure. So that means tan theta A is greater than tan theta B. Or I can say velocity of A is greater than velocity of B. Simple, right? So these are the some of the questions which are asked repeatedly. Again, I do things because in some of the NEET examination also that was asked earlier. Okay, nowadays it was not asked. Okay, now similarly, okay, we'll go for a simple question, and it was a NEET question, guys. It was very easy. So if and all you get in a questions like this, be happy. Suppose this is my displacement time, right? And the graph is like this, right? And you are given 4 options for velocity time graph, equivalent for this. Okay, velocity time graph. I'm not going to write the axis. All right, so out of this, sorry, let's change this one. I drew wrong. Let's write the next option like this. This is axis and this one, right? So all are velocity, 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 right? So these are options. This is option A, option B, option C, and option D. So you are asked for this displacement time graph, which one of the velocity time graph is true. So how would you know? Say, so first of all, look for the angle. This is angle, right? Angle theta is greater than 90 degree. That means velocity is what? Negative, right? So I will look for an option where velocity is negative. This is a positive velocity graph. This is also positive velocity graph. So either this one and this one, right? Now look here, for this point the velocity, let's say this angle is theta. For this point this angle is theta. For this point this angle, right, theta. So the angle is not changing, so V is negative and it is constant, right? So negative and constant means the option is this one. Yeah, this is how you are supposed to do a NEET question. Simple, right? See guys, when if you are not understanding the concept, pause the video and listen it again and again. Until and unless it is clear, don't stop or don't go for the next section. Right, now let's do then another question. This displacement time graph. Let's say let's understand what will the velocity acceleration time for this. Right, let's consider the first segment A and B. Right, from A to B, see, this will be my slope, right? One angle is less than 90 degree, right? This one. So, and the slope is increasing, right? So the velocity from A to B is what? Positive. Simple. And in that part, that is from A to B, the concave is downward, right? So the acceleration will be negative. Clear? Simple. Now at B, at this point, that is at B, so this section, so at B, and when I draw the slope, it is like this, right? That means the slope is straight. So the slope, there is no slope, means the acceleration is 0, right? Clear? Because not acceleration, sorry guys, it is velocity, right? This is displacement time graph. So Now slope in displacement time graph means velocity is 0. When velocity is 0, so obviously acceleration is also 0, right? Now C, that is from part B to C, that is this section. Again draw a slope, right? How is this angle taken? Like this, right? So the angle is greater than 90 degree means velocity is negative, right? And in this section again the BC part is downwards, right? The concave downward means acceleration is what? It is negative. Clear? Right. Now there is an additional part which is never mentioned in any of your textbook, which I am telling you. See, if velocity and acceleration are of same sign means both are either positive or negative, then it means that the speed is increasing, right? If either of them are of opposite side, then speed is decreasing. Just keep that in mind. It is not relevant for your examination point of view. I'm just telling you guys. Okay, so we have done a lot of questions. Then I will be trying to sending you some homework questions. Try to do it. Okay, it's not that tough. Don't make it complicated. Okay.